things to do when you're faced with a trigonometry question, actually any question to do with triangles, is to make the decision on what formula to use. You have all of the formulas on your formula sheet, but you have to decide which one to use. And so what we find when we are marking questions is we get all of these numbers kind of jumbled in and you go, yeah, that's fine. Because it doesn't work, you'll start putting an angle in instead of a side, or a side in instead of an angle, to try and force it into the equation that you want to use. Better still is to actually make the correct decision on which formula to use. So if this is not relevant to you, just move on quietly, but this is my decision tree, and every trigonometry problem that I've encountered, including those really hard 3D ones that we have to do, you can model through with this decision tree. So it's a series of questions. Each question has a yes-no answer. Each yes-no answer takes us down a different path of the tree. And once you've got the right idea, you'll find that it's really quite easy. So the first question we ask ourselves, we're faced with a triangle, we ask ourselves, is it right angled? So this is our first decision, or our first question. Now, as I said, there's two outcomes here, and I'm going to draw them nice and big because I want my board to actually be divided in two, because the first decision is our big split. So I wasn't going to do that one in red because it was going to be my yes, which I was going to do in green. Yes. If it's not yes, it's a maybe. No. There's very few maybes. Right. Let's focus on our yes. And yes is the one that I find students really struggle because they immediately want to run down this line. But sometimes we give you really lovely, nice questions that deal with right angle triangles. So the next question we ask ourselves is, are you dealing with three sides? Now when I say... What for that? When I say are you dealing with, one of these will be unknown. I don't know which one it is, but one of them will be unknown. So are you dealing with three sides? Again, if your answer is yes to that, then you've actually arrived at a solution. If I'm dealing with a right angle triangle and three sides, which rule am I pulling out of my hat? Pythagoras. So have a look and see, can I answer this using Pythagoras' theorem? And often you will be able to. In one of the practice papers there was a question that looked really complex and it ended up just being a series of Pythagoras' theorem. If you're not dealing with three sides, so we go down the no branch, Sarang. Yeah. What could we else be dealing with? Well, are we dealing with sides and angles? Any number of sides and angles, because sometimes we disguise them. We've already picked that it's a right angle triangle. We're dealing with sides and angles. I've got my no branch, which we'll talk about in a second, and my yes branch. Now, if it's my yes branch, what's it going to be? I arrive at another, I can use these set of formulas. Which ones?
Sine and sine cosine.
Good. All of your trig ratios. So you've got your sine.
Wait, sine rule or sine cosine?
Cos, just straight trig. And this is, and Sarang, thank you for demonstrating it so beautifully as you are wont to do. This is the problem. People go, sine rule, but that's not here. That's over here, and that's why I put that big dividing line down the centre. Now, here's my little caveat to that. It will work, but it's the complicated way around. And when we do things the complicated way around, we make mistakes. Okay? If it's a no, my final question is, did the question actually just say area? And probably the answer is yes. If the answer is no to that one, I'm going to suggest you made a wrong turn. Okay? Because this is pretty much what we can do with our right angle triangles. Who can tell me the formula for a right angle triangle area? Now, again, we will arrive at another area formula on that side. It will work, but it won't work as nicely and people make mistakes. That's our decision tree for right angle triangles. Are there any questions?
No.
The most important thing to remember is think about it first, because most people just launch down this side of the board without thinking this first question through. Are we ready for the no branch? Is it a right angle triangle? No. The first thing I'm going to ask is, are you dealing, Sarang, with 3 sides and 1 angle? Now when I say dealing with, remember that just means one of those is the unknown. It might be that the angle's unknown. It might be that one of my sides is unknown. But I look and I say, oh yeah, I've got 3 sides on that. Notice it reflects, am I dealing with 3 sides? Here I need to include that angle. What do you think the answer is if it's yes? Yes, I'm dealing with all of those. Max? Cosine rule.
3 sides and an angle. Oh, that, yeah.
And it's some version of this.
Pythagoras Theorem plus extra.
Yeah, cos C, sorry. I'm lots and lots of practice.
For example,
It's in the
why
formula
would
sheet.
it be sine rule? If you've got 3 sides and an angle.
Because when I do sine rule, I have to go side matched with an angle, side matched with an angle. So what am I dealing with there? 2 angles, 2 sides. Now sometimes, and here's the tricky bit, because we're about to continue and Zaki's question is really relevant. Sometimes the answer to this is I'm dealing with 3 sides and 2 angles. That does not qualify.
I guess my question was, is it provided with 2 sides and 1 angle?
So one of those is your unknown.
Gotcha.
Okay? All right. Of course, if it's a yes, then we have a no. If it's a no, I say to myself, well, is it 2 sides and 2 angles? Now again,
Yes.
that's the answer. But again, this might be cunningly disguised, Sarang. Shh. This might be cunningly disguised in that it might be 3 sides and 2 angles. The 2 angles is usually the hidden trick. Usually.
And then if it's angles, you have,
Hang on. If it's all angles?
you have to do the sine A of the.
Oh yes, there's the different versions of them, yes. Yep. And notice I'm not writing all the versions, and the reason I'm not even actually going to write the sine rule, the reason I'm not doing that is because it's on your formula sheet. So is the cosine rule. I like that one because it ties in with Pythagoras. But other than that. All right. No. Yep.
Aren't there like 2 versions for cosine rule, like one for sine and one for angles?
Yep.
So that's for.
Do you want me to write the other one?
That was
This one's for sides.
yeah.
Tell me the other one.
Just the underneath it. So it's like what cos C equals A squared plus B squared minus C squared over 2AB.
Oh, you must have a really good memory.
It's on the phone.
All right, a couple of points here. What's really important with our cosine rule is this side, C, is opposite this angle C. The 2 ends are opposite each other. That's the most confusing thing with that. There are also 2 versions of the sine rule, also on your formula sheet.
There's 1.
Oh, 1 and then flip upside down.
Yeah, just know that.
All right. So sine rule, cosine rule. If it's still a no, well, what happened after we went to here? We went, is it an area?
You have to segment it.
And if the answer to that is yes, then what's our area formula for a non-right angled triangle? Alrighty, that's your decision tree. Now again, if you get to your bottom branch and you're still answering no's, you've probably done a wrong turn somewhere. Last thing I want to say. Shh. Last thing I want to say. The formulas are labelled very particularly. Every side is a lowercase letter. Every angle is a capital. And the capitals and the lowercase letters match. So when we have our cosine rule, we have side, 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 and this side is opposite this big angle. When we do our sine rule, it's little a, so side A over angle big A. These are not accidents. These are meant to give you hints. And if you're trying to squeeze a side into an angle, more usually an angle into a side, then you're going to get yourself all mixed up.